Hi everyone, welcome to today's webinar. Today before we start our webinar, I'd just like to point out that RSK is running a whole bunch of webinars in a big series, and if you go to developers.rsk.co/webinars, you'll get to this page in which you can see all the upcoming webinars. And you will also see the webinars that we've run in the past. Now, today's webinar will be easier to follow along if you already know how to use MetaMask with RSK, and you also have a tiny bit of understanding of Solidity syntax, because we will be looking at those things, but we won't actually be going to them into a lot of detail. So go ahead and check out our past recordings and come back to this one if you would like to. Okay, so that being said, let's start today's webinar. Hi everyone, welcome to today's webinar, and today we will be talking about how to create a front end with an injected Web3 provider. I'm Brendan, and I'm a developer advocate at RSK. And a little bit about myself: I'm in Singapore. I've been a JavaScript developer, a Node.js developer for a while, and I run this tech meetup called DapsDev Club, which teaches attendees who don't know anything about blockchain, and goes all the way up to being able to develop your first DApp. I'm also currently on day 150 of learning Spanish, so got a way to go yet. All right, today's topic. Here are the things that we're going to be learning today. We'll cover a few key terms. We'll also be talking about browser plugin wallets and how they make use of injected Web3 providers. And finally, we'll round it up with a hands-on session in which we will use Remix. We'll create a simple website and run it locally, and we'll also be talking to a smart contract. So these terms, we have covered them before. However, we're not going to cover them all over again, but I'll just sort of repeat a few of them that are more pertinent to today's webinar, today's topic. So whenever you change the states on a blockchain, it has to come from a transaction. So a transaction is something that is you can think of it as an action, and it is signed using a private key. And when that transaction is successfully added to a block by a miner being someone who's running a node, then that state change becomes accepted, if you will, and that's the new state of the blockchain. And this state can be used to encode transactions, and it can also like transactions of transfers of units of cryptocurrency from one account to another, but it can also be used to encode state changes in smart contracts. So how programs change the values that they need to store. So the miners, who are the ones running the nodes that are mining these transactions, they incur a cost, either computational cost or storage cost, and they need to be compensated, and that is gas, and the gas is paid for using the native unit of currency, which is, in the case of RSK, RBTC for the mainnet and TRBTC for the testnet. All right. So also in the previous webinar, you would have seen this diagram before, but today we'll be going into a bit more detail, and we'll be focusing on these three on the left, because today's focus is on the front end. These three on the right, they're actually the focus for other topics. This is like going towards the back end. So very briefly, a browser talks to an injected Web3 provider, which talks to a browser plugin wallet, which signs the transactions and transmits them over JSON RPC, which is the network protocol, and that talks to RSK, which is a blockchain, and also a smart contract platform, and that talks to another blockchain via two-way peg called Bitcoin, and all of the transactions on the RSK blockchain are pegged or secured using the Bitcoin blockchain. So today's topic will be focusing on these three items. So a browser plugin wallet holds your private key, your cryptographic private key, and you are not allowed, or it's not in your best interest to allow your wallet to divulge its private key to the web page, because you can't really trust that web page and not to leak that information or to otherwise be hacked. So this thing over here, the injected Web3 provider, is something that is used to bridge that gap in such a way that only permits the required information or the necessary information to go between this and this. And how does it do that? It is saying, hey, okay, this web page says, hey, I'm a DApp and I want to interact with a blockchain. Okay, I'm going to go to this injected Web3 provider and I'm going to say, hey, I request to do this. And the browser plugin wallet says, okay, injected Web3 provider has given me this information. Now I'm going to pop up my own dialog and confirm with the user, does this user really want to sign this transaction? If yes, then I will go and sign the transaction and propagate it all the way over here. If not, then it just rejects it. And the private key always stays inside here. It doesn't go to any other entity on this diagram. And that's how this whole setup works. And the injected Web3 provider is actually pivotal for all of this to happen properly, because that's what gives you the separation. So in a browser, a Web3 provider is a JavaScript object, and it's injected into the window global by the plugin. Right. The plugin is responsible for maintaining the crypto keys, the private keys, and therefore for signing transactions. So whenever a transaction needs to be signed, it pops up a dialog to the user saying, hey, do you actually authorize this? And if the user says no, then it doesn't sign it. Pretty much. The DApp itself is not allowed to sign transactions. So it interacts with the blockchain over JSON RPC, which is not our focus, and it interacts with the web page via the Web3 provider that it injects into the window object, and that will be our focus for today. So today we're going to fire up Ethereum, Remix, a Remix IDE, which is provided by Ethereum Foundation. The good thing about RSK is that its compatibility level with Ethereum is very high, and a lot of the Ethereum tools just work out of the box, and Remix is one of them. So let's get our hands dirty and begin with today's hands-on. Okay, everyone, we're about to begin our hands-on for today's webinar. Now, what we're going to do before we start is just point out that if you prefer to follow along in text format, you can go to this URL, developers.rsk.co, and then you can search for how to create your first front end for smart contracts, and you'll find a tutorial which covers this. And yeah, so if you prefer to follow along with text rather than video, then this is what you should check out. I'll provide the links, all the relevant links, including this one, at the end of this webinar. Okay, so let's start. So I'm just going to bring out my notes over here. This link will also be provided to you, obviously. Now. And you can even check out the links for the presentation deck that you just seen. So we've got let's see. Okay, so first up, let's start Remix. So I've already got it open over here. Just open this link in a browser in which you have MetaMask installed. So you'll notice over here, I'm currently in Firefox, but over here I am in Chrome, and I already have MetaMask installed, and I already am connected to the RSK testnet, and I already have it funded with a certain amount of RBTC. Note that it displays ETH here, but actually it is testnet RBTC. That's because of a bug in MetaMask. Yeah, just to show you the point, let's see if I can figure out how to open this in full mode. View and expand view. There you go. So if you go to this one and you click on custom RPC and then you click on RSK testnet, which is what I've connected to, you notice that I put the token symbol inside here and the Block Explorer URL here, but for some reason MetaMask decides that it's going to ignore them in its user interface and just use whatever defaults for Ethereum that it feels like using. So let's just keep that in mind while we continue with this tutorial. Okay, so once we're in, once you've got Remix open, the first thing to do is to click on the Solidity button, and you'll notice on the pane on the left here that there are a bunch of new icons that have appeared. And the ones that we care about are these two, the Solidity compiler as well as this, which allows us to deploy our smart contracts. So let's click on File Explorer. We can shut this down first. Click on File Explorer and click on the circle with a plus icon in it, and go to type in register.sol. So we're creating a new smart contract with that name. Then we're going to do copy this, paste it over here, and now we've got a new smart contract. Now we have run a webinar previously on that goes into details of what Solidity is and its syntax and how to program in it. So please go check that out if you need an introduction. Likewise, you saw earlier on how I've got MetaMask set up and it's already been funded. In order to do that, you can also follow along another one of our previous webinars. We won't go through that again today. So moving on. So this smart contract is by way of orientation. It contains three things. One is a private state variable, which is a string. We have a getter function, which sets the value for this info string, and we also have a setter function. We have a setter function which sets the value for that, and we have a getter function which retrieves that value. So that is that's all there is to that. It's just a simple storage function, enough to demonstrate what we need for today. Now the next thing you'll notice is that on the left pane over here I have the Solidity thing, a Solidity icon with a green check mark. That's happened because I have auto compile checked on, and that's not checked by default. So we don't. So you can go ahead and check that if you like. So what that means is every single time that I type something, it will check the syntax essentially, and that's quite useful. So you can see that I get live feedback. So I can just hover over that and say, oh, there's a parse error, and so I can put that and fix the syntax, and it's compiled all in memory over here. That's pretty handy to have. Now, so we've compiled that already. So the next thing to do is we go to the deploy and run transactions tab, which is this thing over here. Important to note is that if we don't change the environment, the default is JavaScript virtual machine, which means that everything is happening inside the memory of this browser. It is not interacting with an actual blockchain. But today we do actually want to interact with the RSK testnet, so we're going to drop down and select injected Web3 provider. Now you'll notice over here it says custom bracket, and in parentheses you'll see 31 network. 31 is the chain ID of the RSK testnet. The other thing that I'll point out is that I have previously installed MetaMask and have used Remix with this MetaMask installation before. So you'll notice that there was no pop-up at that point in time. Now, if this is your first time using Remix to connect to MetaMask, then what will happen is that you will get a pop-up that's asking you for permission. Hey, do you trust remix.ethereum.org, right, this domain? And you have to say yes, you do, before MetaMask will even allow any DApp to even ask it for permission. So it needs permission for permission to sign transactions. Yeah, so 2 levels of security there. So right now I've whitelisted this domain, and I'm able to then ask it for permission to sign each transaction. Now, what we're going to do is we're going to press deploy. We don't need to care about any of these values. Just make sure that the contract that's selected is register.sol, which is this one over here, and you press deploy. Now, you'll notice over here in MetaMask, that there is currently a contract deployment going on, and it's unapproved. I was expecting a pop-up to occur. Where's that pop-up? Interesting. Aha, okay, so it's because I had it in this expanded mode over here, so it decided to show me the pop-up over here. So I'll just press confirm, right? Now, just to be a little to go into a little bit more detail than is needed in today's session, before I press confirm, I'll check a couple of things. So it's saying, hey, this has 835 bytes of data, and that data is actually all of this stuff. These are actually EVM opcodes, and is one of the outputs of a Solidity compiler. Now, we talked about this in a bit more detail in the previous webinars, so go ahead and check those out. But for now, let's just assume that we trust that this really is the compiler, the Solidity Sol-C compiler output for the smart contract that we did. If you do not trust Remix for whatever reason, to actually have the real data out here, then what you can do is you can verify this data by compiling it like yourself on your own computer and checking that they are the same. So let's assume that you either trust it or you've independently verified it. Then you press confirm. You will pay this amount of gas. So you're paying 0.40 followed by 16. So that fraction of an RBTC token, you're paying for the right to deploy and store this smart contract on the blockchain. Let's go ahead and press confirm. Now we'll need to wait for about 30 seconds. That's the average time taken for a transaction to process on RSK. So we'll just wait for that spinner to finish spinning. In the meantime, while we're waiting, let's work on stuff on locally. So what we're going to do is skip that, copy the address at which it was the contract address that we just got. We're going to do make directory, and let's see, let's make up a name. Front-end injected dash web3 dash provider. Okay, and cd into that folder, and then we're going to do a git init to initialize the Git repository, npm init to initialize npm project. I'm going to accept that name, version like that, description, I'm going to say, let's copy that over here, and then add the word tutorial over there. Now, you saw that little icon, this little pop-up in the tray over there, it has completed. So we can click on that and we can see what the details are, and then we got to a new contract. Now we can copy the transaction ID, or we can view in Explorer. So let's go ahead and do that. It looks like MetaMask has appended or prepended the extra slash. Okay, there we go. So we got a smart contract being deployed. Let's find the smart contract address over here. We click on it. All right, there we go. So here's our smart contract successfully deployed. So I just jumped into that because I got a notification tray, but right now what we're going to do is we're going to continue doing what we did over here, and then we'll jump back into it, into this step. Okay, so let's finish initializing npm. So the entry point, let's just hit enter, get repository. Let's go with this slash this. I'm going to put tutorial over there. And then keywords can be RSK. What else do we want? RSK and Web3. Let's just go with that. Just going with all my usual defaults. Yes. Okay. So now we've got a new folder with a new Git repo and a new npm package over there. So I'm just going to do npm install web3 at that version and express at that version. Let that run. Now that installation is doing Node.js compilation, so it'll take a little bit longer than usual, but now we're done. Alright, so what we're going to do now is we're going to create the files, touch index.html, sorry, index.html, index.js, and server.js. So now I've got 3 files and they're all empty. Let's open up this folder in our code environment. You can see those files are there: index.html, index.js, and server.js. Excellent. Okay, so what we're going to do now is copy the HTML file. This page is kind of lagging a little bit here on me. That is okay, it looks like we're back. Alright, and we'll just copy that and paste it into index.html. There we go. Alright, then next up we have index.js. Let's see. So this address will need to be updated to whatever we just got in Remix. So let's go ahead and do that. Copy that and paste it into index.js. Yeah, and let's go ahead and update this contract address. I'm going to delete it, go to Remix, go to back to the deploy thing. So you'll see here we have just one smart contract. We just want to copy the address of that over here. Value copy to clipboard. Nice little pop-up there. And we paste that the new value. And the other thing that happens is that there's an ABI. It's been preloaded for you, but you can actually get that from the compiler here as well if you wanted to. Yeah. Okay. So yeah. So if we just do a quick search, let's say what's it? Set info. It's over there, and get info is there as well. Both are in the ABI. So just quickly showing you that the functions the ABI basically tells the front end that the smart contract that is at this address is supposed to have functions with those names and those parameters that the compiler output. Okay, so now finally we're going to run the application. Let's go ahead and create a very simple static file server. Feel free to go ahead and use any other method that you feel like. We're just using Express here as a bit of overkill. We could also use HTTP server from the node global like this, npx http-server. If you wanted to, -p, like that would work, or you could use this file. So that's up to you. So I'm just gonna use this file for the moment. Node server.js. All right. So now it's running at localhost 3300. Sorry. Let's just copy that and paste it over here, and there we go. So let's just open up the console over here and look for anything. So we can see that it's connected to account 0xc49 blah blah blah, and if you open up MetaMask, you can see that matches. Okay, so we can see we've established that this domain has connected to MetaMask. Like I mentioned before with Remix, if this is your first time using MetaMask together with this domain, you should expect to see a pop-up prompting you to say, hey, do you trust localhost 3300? And you get to say yes or no. Okay, so first up, what we're going to do is we're going to say, let's do get, right? Wait for a while, and we say we got back info of nothing, and it's also displaying nothing here. That's expected because the contract is like in its constructor state. So whatever it was, just as it was constructed. Now let's just go ahead and say RSK, right, for info, and press set. Now what happens is we get a MetaMask notification with a pop-up saying that, hey, do you want to do this transaction on the RSK testnet to this smart contract address, and you have to pay 0.5 zeros followed by 4, so a very tiny fraction of RBTC in gas, and you can go ahead and inspect the data. So this thing over here actually corresponds to the ID of the function. The Solidity compiler will actually say, in order to call the setInfo function, you have to find the function starting at this address, and that's part of the purpose of the ABI, helping the front end to work that out. And then over here, you can see the data, right? So let's see, 4B53. There we go. So if you actually were to convert that into from RSK ASCII into text, I'd say that that's the hexadecimal representation of RSK. Now let's just go ahead and verify that. So convert ASCII to hexadecimal. ASCII to hex seems reasonable. Let's go RSK and convert. There you go, 52, 53, 40, and 4B, so over there. So I'm not sure what the 03 is, but you can see that RSK is inside there. So that was just for a bit of confirmation of what the data actually is. So let's go ahead and press confirm, and now we have to wait for about 30 odd seconds for the transaction to get mined by the miners, and we should see a pop-up when that happens. So you can see the contract interaction is pending, and we'll go ahead and look at that there as well, give us a bit more detail. Yeah, and when that completes, we're expecting to see a pop-up. All right, there we go. So if you do that, you can go to view at explorer.testnet.rsk.co, and as we had to do before, we have to remove that extra slash, and there we go. We see a successful transaction. We can see the same data that we confirmed earlier on, and we can verify that the to address of the transaction